to remember because I find that you start getting yourself a little confused when we do that. Franklin, what you doing over there, buddy?
You got pencil sharpener this morning?
Yeah, here, I'll show you.
Yo, I wrote 5.
See, now we've started the lesson. That's not appropriate.
Nothing.
All right. So, when I talk about special patterns, we're really just going to multiply. Okay? So, when we have things like, let's say 3x plus 4 to the second power, what does it mean to be to the second power? Don't just you're not quite saying it right, but I think you're on the right path. You can't distribute that because you're adding inside the parentheses. If you were multiplying the parentheses, you could. So what the exponent tells us is it tells us how many times to multiply it. So this tells us multiply by itself. Okay, so in other words, I'm going to write it 2 times. It tells us how many times to write it out to multiply. So if I write this twice, I get 3x plus 4 and 3x plus 4, right? Do you know how to multiply that? You should. This is what we did Friday. We start distributing, okay? So we take the first term and it distributes to everything. So what is 3x times 3x? 9x squared. Why is it squared? Because these have imaginary ones here, right? Ricky, sit up, wake up. Now it goes to the next term. What is 3x times 4? 12x. Remember when we multiply coefficients and we add exponents on the variable. All right. I'm done with this, so I move on to the next one. What is 4 times 3x? Another 12x. Distribute it through to everything, so 4 times 4 is 16. Am I done?
No.
Nope, almost, but I got one more step. What's that other step? Combine like terms. Which ones are like terms? 12x and 12x. That's exactly right. Good job. Say, instead of an exponent, let's say we had 2 things like this. Can you multiply that out? Sure. We're going to, again, that's right, we're going to start distributing. So take the first term and distribute it through. What is 3x times 3x? Squared, that's right. We haven't really seen one like this. What is 3x times negative y? Negative. Somebody said negative, that's right. I got a positive times a negative, so it's definitely going to be a negative. There's one y, there's one x, and there's a 3. 3x times y.
Oh, I was thinking that. What?
Just put them together. When you multiply variables, you just put them together. It's not another x.
Well, what? I don't understand. How you got it?
The 3 was, I distributed this 3x through. Yeah, so I did 3x times negative y. Right? Negative y, there is an imaginary one there, so times negative 1y. So I can multiply the numbers in front, that gives me negative 3. And these don't have the same base, so I just write them. Okay? I'm done with this first term, so now let's look at the second. What about y times 3x? Positive 3xy, right? Positive 3xy. And then y times negative y. Negative 1y squared. Okay? Don't forget those squareds whenever you have an imaginary 1 as an exponent. Now, this one is special. Look at those 2 middle terms. What do you see? What happened? They're the same but with opposite signs, right? They cancel out. They cancel out.
9x minus
9x squared minus y squared. Okay? This is a special pattern because these were exactly the same, but one was a plus and one was a minus whenever we multiplied them out. And every time you have one like that, these middles cancel out. That's why they call it a special pattern. But the technique is the same. We just multiply and distribute through just like we did before. Let's do another.
So we're not gonna have
Probably have classwork.
No, let's not have classwork.
Yes,
I'd rather
no.
have homework. Yes, I'm not gonna finish classwork.
Try this one. Tell me what you get.
Oh, you write the 5x.
Oh, she said
Do
write
it.
down and
Do it.
Right.
Oh,
Right, so the exponent tells us to write it 2 times, and now I'm going to start distributing.
Oh my gosh, bro.
5x first. What is 5x times 5x?
squared.
Y'all are forgetting that squared. Don't forget the squared when you multiply the two variables together. All right, what about 5x times negative 2y?
Negative 2xy.
Okay, I'm done with this one. Let's do the next. Negative 2y times 5x. Negative, yeah, or it doesn't matter the order, whatever order. Yep. How about negative 2y times negative 2y? Positive 4y squared. Because a negative times a negative, Christian, be nice, is a positive. Now, as you look at this one, the signs in the middle on the two are not opposites, they're the same. So I need to combine like terms, right? What is negative 10xy and negative 10xy? Negative 20. It would, if they were, no, if they were opposite signs, it would be, okay? But because they're the same signs, we combine the numbers in front to get 20xy plus 4y squared.
10 plus
10,
10?
yeah.
Boy, no.
These two add together,
No, it's still wrong. I thought,
What do you mean?
okay?
I don't even know.
This one, you could, in ones that have more than one variable, you can just leave them the way they are there. Tell me what you think.
I think I'm